Electrovalent or ionic compounds and their properties. Compounds composed of cations and anions are called ionic compounds. Sodium chloride composed of sodium cations and chloride anions. Calcium oxide containing calcium cations and oxide anions. And magnesium chloride having magnesium cations and chloride anions are all ionic in nature. In all these compounds, the oppositely charged ions are held together by strong electrostatic forces of attraction. Let's study how ionic bonds are formed. Consider the reaction between a sodium atom and a chlorine atom. The sodium atom loses its valence electron, which in turn is accepted by a chlorine atom. Both the atoms thus achieve a stable octet configuration, and an electrostatic force of attraction called the ionic bond develops between them. Similarly, a metal like calcium loses its two outermost electrons in a non-metal like oxygen, resulting in an ionic bond in calcium oxide. On similar lines, magnesium loses two of its electrons, which are accepted by two chlorine atoms, resulting in magnesium chloride MgCl2. It is interesting to note here that the metal always forms a cation, while the non-metal forms an anion in all these cases. We shall now discuss the characteristic properties of electrovalent compounds. Most ionic compounds are crystalline solids at room temperature. Their constituent ions attract one another strongly and are arranged in a repeating three-dimensional pattern. It is this arrangement that gives to the crystal a characteristic geometrical shape. As the ions are held together by very strong attractive forces, ionic compounds generally have high melting points. In their solid state, ionic compounds are non-conductors of electricity. When heated to temperatures above their melting points, the electrostatic force of attraction between the ions breaks and the ions become free to move. These free ions can now allow the passage of electricity. Let us discuss the solubility of ionic compounds in water, which is a polar solvent. When an ionic compound like sodium chloride is added to water, the negative end of the water molecule attracts the cations and pulls them out of the crystal. Likewise, the positive end of the water molecule pulls out the anions, resulting in dissolution of the compound in water. Thus, ionic compounds are soluble in polar solvents like water.